Alright, so we're going to go over the last section of our modeling. I know this section was a little bit difficult, but it's super important because these are things that you can use in the real life, okay? In the real world. So here it says Anna deposits $450 every month into an account earning a monthly interest rate of 0.5%. How many months would it be until Anna had $9,000 in the account to the nearest month? Use this following formula to determine your answer. Okay, so I'm going to go ahead and go through all of this. It does say that she deposits $450 every month. Now remember, we do have to take into account what they're giving us. Is it every month? Is it every year? And all of them need to match up. If one says months and the other one says years and the other one says quarterly, we need to convert it so that they're all within the same time frame, whether it's monthly, quarterly, annually, whatever it is. Okay, so this one says it deposits $450 every month. Okay, so the letter D stands for the deposits, so it's $450 per month. And I'm going to write here the months just so I make sure everything matches up. Okay, that's a deposit. Okay, and then it says into an account earning a monthly interest rate. Okay, so see how our interest rate is also monthly? So we have no conversions to do there. Okay, the interest rate per period, well, our periods are all the same right now. They are monthly. So it's an interest rate of 0.5%. This is a monthly interest rate. Okay. Now remember, when we do plug this into the formula, we do have to write it as a decimal. So this is going to be 0.05 as a decimal. All right, and then it says how many months. Okay, so we are looking for the number of periods because it's saying how many months. What it takes. So I'm going to put here for N. We don't know what that is. We are looking for it. Okay. In terms of months. And then it says, would it be until Anna had $9,000 in the account? Okay, so that's the amount, the future value that they want in the account. Okay, so A is 9,000. So now this time we're going to have to solve for N. Okay, so I'm going to go ahead and plug all of this into our formula here. Sorry. All right, so it's going to be A. We know A is equal to 9,000. So I'm going to put 9,000. 9,000. 3, because that's how much we want in the account. Okay. The deposits that we're going to make are going to be $450 per month. So $450. Okay, and then I'm going to go ahead and copy down the part that doesn't change, which is these parentheses. We have the division sign. It'll be 1 plus our interest rate to the n power minus 1. All right, my interest rate I is 0. Oh, you know what? It's 0.005. Okay, because it's 0.5%. So I do need to fill in those two zeros. So it's 0.005. 0.005. And then what we're looking for is the number of periods, the number of months. So we're going to leave that as N, and then we're going to slowly start solving for N. Okay, so first we're going to go ahead and get rid of that 450 that's here. So I'm going to divide both sides by 450. This cancels. Let me go ahead and put this in my calculator real quick. Nine, 1, 2, 3, divided by 450. That gives me 20. So 20 equals, okay, now I have this 0.005 in the denominator, minus 1. We have this to the n power. I'm going to go ahead and add these two numbers together, the 1 plus 0.005, and that gives me 1.005. Okay. Now my next step is to get rid of this 0.005 in the denominator. So the way that we do that is by multiplying both sides by 0.005. Okay. All right, and then from there, that gives me 0.125, gives me 0.1 equals. Okay, these ones cancel out, and I get 1.005 to the n power minus 1. Okay, then this minus 1, I'm going to go ahead and move it to the other side by adding 1. And this is going to give me 1.1 equals 1.005 to the power of n. And then, remember when we're solving for exponents, we need to change it into log form. Okay, so here I'm going to do log. My base is 1.005 of 1.1 is equal to my exponent. My exponent is n. Okay, I'm going to go ahead and put that in my calculator exactly the way I see it. And this gives me 19.1. So 19.1 equals n. And in the problem, it does tell me to round to the nearest month. So 19.1 would round to 19 months. 19 months. All right, moving on to the next one. Here it says Zoe deposits $300 every month. Okay, so the deposits are 300. D, the amount invested at the end of each period. Okay, so we have $300 every month. Okay, into an account earning an annual interest rate of 8.1%. Okay, this is annual interest rate, but we do need it to be compounded monthly. Okay, so this 8.1%, we're gonna have to take it because it's an annual interest rate. I'm gonna take I, and I'm gonna have to take our interest rate, which is 0.081. And I am going to have to divide it by 12, okay, because this is the annual interest rate. And I need to change it to monthly because my deposits are monthly, it's compounded monthly, and we're going to look for how many months, okay? So I'm going to have to divide that by 12 because there's 12 months in a year. So 0.081 divided by 12 gives me 0.00675. Okay, and then from there it says how many months. That's telling us that we're looking for the number of periods in terms of months. Okay, and then would it be until Zoe had $12,000? So when her final amount would be $12,000. So A equals 12,000. Okay, so we go ahead and start plugging it in. So A stands for the amount after a certain number of periods. So A is going to be 12,000. So 12,000 equals. And then D stands for the deposit. So she's depositing 3,000 per, oh no, not 3,000, 300. Okay. And then from there it says her interest rate per period is going to be plugged in here and here. Okay, so I'm going to go ahead and copy everything else down real quick. Do the parentheses, this part goes in parentheses, it's going to be 1 plus, out here is minus 1. And then we plug in our I. So our I is 0.00675. 0.00675. And then we don't know what the number of periods is. That's what we're looking for. So I'm going to go ahead and start solving for n. So we start off by getting rid of the 300 in the front by dividing both sides by 300. This gives us 4, let's see, 12, 2, 3, divided 40 equals. Then I have 1 plus 0.00675 to the power of n. I should have added that. Let me add that real quick. It'll just be 1 point that. 1 0.00675 to the n power minus 1 over 0.00675. Okay. Then you multiply both sides by the denominator to get rid of the denominator. So times 0.00675. We're going to take this and multiply it times 0.00675. So this side cancels out. Okay, and on this side, I'm going to go ahead and multiply 0.0065 times 40, and that gives me 0.27 equals 1.00675 to the n power minus 1. Then I'm going to go ahead and add 1 to both sides, and I get 1.27 equals 1.00675 to the n power. Okay, let me go ahead and scroll up a little bit. And then once we have it like that, we can go ahead and change it into log form. So it'll be log, our base is a 1.00675. This is 1.27 equals our exponent. I go ahead and plug that into my calculator and it gives me 35.5. And it does say to round to the nearest month. So that means that I'm going to have to go for 36 months of putting $300 into an account in order for me to end up with $12,000 with an annual interest rate of 8.1%. Okay. All right, the last one. Okay, so here it says Emma deposits $100 every month into an account earning an annual interest rate of 5.7% compounded monthly. How many months would it be until Emma had $4,000 in the account to the nearest month? Use the following formula to determine your answer. All right, so her deposits are the letter D. She is putting in $100 every month. So D equals 100 every month. Okay, and then next it says that it earns an annual interest rate of 5.7% compounded monthly. Okay, so because it is an annual interest rate I, 5.7%, so 0.057, we are going to have to divide that by 12 in order to convert it to months like all of them. So I'm going to go ahead and do that real quick. And that gives me 0.00475. Okay, and that's for my annual interest rate I. Okay, then it asks how many months. So because they're asking how many months, that means that we're looking for n equals question mark in terms of months. Okay, and then it says, would it be until Emma had $4,000 in her account? So we're going to see how long it's going to take her to get $4,000 into the account. So A equals $4,000. This one. This one. Okay, so I'm going to go ahead and plug all that into my formula. I have A is 4,000 equals D is $100 per month. I'm going to go ahead and do the part in the parentheses. This part is 1 plus, out here is minus 1. Okay, and so I said my interest rate is going to be 0.00475. 0.00475. And then the n, we don't know what it is. That's what we're looking for. So this is to the power of n. Okay, so first we start off by dividing both sides by 100 to cancel out the 100. So these you all solve the exact same way. So this gives me 40 equals, and then on the top, I have 1.00475 once I add those two together to the n power minus 1, and then on the bottom I have 0.00475. Then we multiply both sides by 0.00475, and I do the same thing here, 0.00475. Okay, then let me go ahead and put that in, 40 times 0.00475. Enter. 0.19 equals, this cancels, we have 1.00475 to the power of n minus 1. Okay, then we're going to go ahead and add 1 to both sides, so plus 1, we get 1.19 equals 1.00475 to the power of n. Okay, once you have that number to the exponent by itself, you're ready to change it into log form. So it's going to be log, the base is 1.00475, 1.19 equals n. So I'm going to go ahead and put that in my calculator exactly the way I see it. Enter. Gives you 36.7. And remember, this is in months, so that we're rounding to the nearest month. That would be 37 months. And that's it. Thank you, guys. Bye.